All right, in the last video, we looked at binary to decimal conversions, and in this one, I want to do the opposite, and I want to go from decimal to binary. But before we do that, just so we can examine the pattern again, I want to review one example of binary to decimal. So binary to decimal here, okay? And let's just take the example 1, 1, 0, 1, 1, just make up some numbers, and turn this to decimal. So like here, let's count our place values. That's 0, 1, 2, 3, 4. So this one represents a 2 to the 4th power. That one is a 2 to the 3rd power. We don't have a 2 to the 0 because we have a 2 to the 0 in that place. So this would be a 2 to the 1st, and this would be a 2 to the 0. And so I'll work that out. 16 plus 8 plus 2 plus 1. And let's see, 16, that's 24, 26, and 27. Right, so 27 would be the decimal representation of 11011. So now we need to think about reversing the process. And when I say reversing the process, I'm really looking at how can I get to this step. And this is what I'm looking at is how can I take this number 27 and I'm going to express it as a sum of powers of 2. Okay, so let's do it. Let's try one. We'll try the number 57. Okay, so this will be the example. And before I try this, I just want to do one more thing real quick. Something that's useful to have is I would memorize this, or at least if not memorize it, be able to rattle off the numbers real quick. But I want to know my powers of 2. So like 2 to the 0 is, let's see, it is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8th is 256, 2 to the 9th is 512, 2 to the 10th is 1024. And if I wanted to keep going, I could. It's pretty easy. Just keep doubling the number. You can do it in your head for quite a while. And if you don't have this memorized, it's nice to have a little cheat sheet next to you when you're doing the conversions. So let's take this number 57. The first thing I'm going to do is I'm going to move over here, and I'm going to go, which power of 2 is the largest one that I can take away from 57? So in this case, it's going to be the 32. And that happens to be a 2 to the 5th power. And so that leaves me with 25. And then I go back over here and I can take away a 16, which is a 2 to the 4th, leaves me with 9. I can take away an 8, which is a 2 to the 3rd power, leaves me with 1. And then I can take away a 1, which is a 2 to the 0th power, and I have nothing left. And so 57, what I've learned is I can express it as 2 to the 5th plus 2 to the 4th plus 2 to the 3rd plus 2 to the 0th. And so now I just want to turn that into binary. So what I'm going to do is I say, well, there's a 2 to the 5th, there's a 2 to the 4th, there's a 2 to the 3rd, there is no 2 squared in the sum, so we'll put a 0. There is no 2 to the 1st in the sum, so we'll put another 0. And there is a 2 to the 0th, and there we have it. This is the binary representation of decimal 57. All right, I'll try one more. And I'm going to just, when I try it, I think I'm just going to keep my little power of 2 list handy so we can use it as a cheat sheet. And so let's try the number, another example, we'll try 720. Okay, so 720, let's see. We'll go back over here. Biggest number is 512. So let's see, that's a 2 to the 9th, and we take that away, and I've got 208 left. So I can take away a 128, which is a 2 to the 7th, and that leaves me with 80. Let's see, I can get a 64 out of it. It's a 2 to the 6th. leaves me with 16, which is the power of 2 already, so I can take away 16. Ends in a 0, so I'm done. And there I got my 2 to the 4th. And when I want to go ahead and express this in binary, all I have to do is it's 2 to the 9th plus 2 to the 7th plus 2 to the 6th plus 2 to the 4th. So I just go 9, no 2 to the 8th, so we'll put a 0. There's a 7, there's a 6, no 5. And then I go, there's a 4, and then I go 3, 2, 1, 0. All right, because there are no 2 to the 3rd squared first and 0th powers in there. So this is 720. This is the binary representation of the number 720. All right, so before I end the video, what I'm going to do is just put 2 more problems up here, and these will be for you to try. And I would just get out a piece of scratch paper, and I would say take the number 90, so this will be your decimal number, and see what its binary equivalent is. And then how about try 397 and see what its binary equivalent is. And pause the video, and then in a few seconds, I'll put up the solutions. Okay, hopefully you're able to work this out. And so the number 90, if you did it correctly, it should have been 1, 0, 1, 1, 0, 1, 0. And 397 should have been 1, 1, 0, 0, 0, 1, 1, 0, 1. And I would say if you didn't get those solutions, maybe rewatch a couple of the examples that I did and give it another shot. So thank you for watching.